Machine learning constantly asks one question: how close are two things? Two customers, two images, two predictions. To answer it, we need to measure distance in the space of data. And there is more than one way to measure, each with its own personality. The length of a vector is called its norm. The everyday one is the Euclidean norm straight line distance, straight from Pythagoras. For a vector, it is the square root of the sum of its squared components. It is written with double bars and it answers, how long is this arrow? Distance between 2 points is just the norm of their difference. Subtract one vector from the other to get the arrow that connects them, then take its length. For the points 1, 1 and 4, 5, the difference is 3, 4 and its length is 5. A clean right triangle answer. But straight line is not the only distance. Imagine a city laid out in blocks. You cannot cut through buildings, you walk along the streets. That is the Manhattan distance. Add up the horizontal and vertical steps. 3 across plus 4 up equals 7 blocks, same 2 points, a different, equally valid distance. These have names, the L2 norm for straight line and the L1 norm for city blocks. They behave differently. The L2 norm punishes big errors harder because it squares them. The L1 norm treats all errors evenly and tends to push small ones to exactly 0. Choosing between them shapes how a model learns. Sometimes distance is the wrong question. Two documents might be far apart simply because one is longer. So we often use cosine distance instead, comparing direction, not length, using the cosine similarity from Chapter 4. For text and embeddings, direction usually captures meaning better than raw distance. This is the machinery behind so much of machine learning. Nearest neighbor classifiers label a new point by the distance to known ones. Clustering groups points that sit close together. And nearly every model measures its error as a distance between its prediction and the truth. Distance is how a model knows it is wrong. So distance and norms. The norm is a vector's length, distance is the norm of the difference. Straight line L2, city block L1, or cosine for direction, each measures closeness differently. And closeness is the heartbeat of prediction. Next, the shapes that separate our data, Chapter 10, hyperplanes.